Here we have a function g of x is equal to 5x squared plus 4x plus 2, which I took the liberty of drawing really nicely here. And our goal is to take the tangent of this function at x is equal to negative 1. So let's try doing this. Whenever you're faced with this problem, all you have to remember is the formula that we're going to use, which is y is equal to m times x minus x1, okay, plus y1, which, if you notice, is a little bit similar to y is equal to mx plus b. So we need a few pieces of information in order to be able to solve this problem. Okay, first we need our x1, we need our y1, and we need our m. So how do we get these things? Our x1 is actually already given to us. Our x1 is just negative 1. Okay, it's this one. Okay, that's one part done. Our y1 is a little more complex. So our y1 is found by substituting our x, this x, into our original function over here. Okay, so let's try doing that now. 5 times negative 1 squared plus 4 times negative 1 plus 2. Okay, remember that negative 1 squared is just positive 1, so that gives us 5 minus 4 plus 2, which is simply equal to 3. Okay, so I moved over some of our already known information over here, so we have more space to work. But essentially, our m, which is our last piece of the puzzle, is just the slope of our tangent line at this very specific point. X is equal to negative 1, and y is equal to 3. Okay, if you want to know how to get the slope at that specific point, we'll need to find derivatives. And if you're asking yourself, why we need to find the derivative of the function at that point, you can look at my previous video called What are Derivatives? Okay, so let's try that. Our first step is to take the derivative of g of x. Okay, so let's write it as g prime of x is equal to, now we use the power rule and we bring down the 2, so we multiply 2 times 5x raised to 2 minus 1, okay, plus 4. So we just remove the x over here, plus 0, because this is a constant. And so our g prime of x is equal to 10x plus 4. And similarly to what we did for this y1, we can actually just plug in our x1 into g prime of x. So that would look like this. Our m is equal to 10 times, okay, 10 times our negative 1, which is our x, plus 4. And so this would equal to negative 6. And now we have all pieces of the puzzle, so we can write out our final tangent line equation. Y is equal to m is negative 6 times x minus x1 is minus negative 1 plus 3. So this finally gives us, after simplifying, y is equal to negative 6 times x plus 1 plus 3. So this is the equation of a tangent line at our specific point, negative 1, 3, in this g of x function. In summary, you can kind of just follow this 4-step process. The x1 is always given, then you plug it into the original function to get y1, then you plug in x1 in the derivative of the original function to get m, and finally you just fill out our formula, which is y is equal to m times x minus x1 plus y1. By the way, whenever you do problems like these and you're doubtful, you can actually use this app called Desmos. Okay, here I inputted our original function and our tangent equation, and you'll see that in this original function, our tangent equation perfectly lies at negative 1, 3, and it's a perfect tangent to that point. So that's how you know that you did it correctly.